rushed in the last video because I was just trying to make sure I finished the video on time. Okay, so I have this box plot drawn for the I've shown the outliers here as well. Okay, now the data set that we were dealing with is the first one that we drew here. All right, and I said I'm just going to add these extra points to this data set as well. All right, and we did the test for the outlier. All right, so the test of an outlier in the upper extreme is to times the interquartile range by 1.5 and then add it to the upper quartile, which is 47, and that's 53.5. okay, and then we saw that there was one point which was above that value, which is 110. okay, and we do a similar sort of test to identify an outlier at the lower end. Okay, so we take away that value, that's 1.5 times the interquartile range, from the lower quartile, and we get 19.5. So if any value is less than 19.5, it's an outlier. So 2 is an outlier, and 14 is also an outlier. Okay, 14 and 2 were found in the original data set. Okay, so there was a 14, so there's a 14 here somewhere. Where could I see the 14? Yeah, there we go, it's 14 there and 2. Alright, okay, and you do not include them in the box plot, the outliers. You've got to show them as a cross, and the next value that satisfies the criteria for the outlier, which isn't an outlier, needs to be included as the lowest value and the highest value there. Alright, okay. Now we look something called skew. Alright, skewness of a data set. Okay, now there are two types of skew, well, three actually. So you can get, let me get the right color there, hold on one second. You can get positively skewed data. Alright, you can get negatively skewed data, or you can get symmetrical data. Alright, which is symmetrical about the center. Okay, so that's positively skewed, that's negatively skewed, and that's symmetrical. Okay, now it is a bit difficult actually to remember which one's which, because I tend to always think that this is negative and this is positive, because I think of the number line, and because it's going towards the negative end of the number line, and I think that 0 is in the middle. Oh, I think this is negatively skewed and this is positively skewed. Okay, but remember, this is positively skewed and this is negatively skewed. Okay, and this is symmetrical. Okay, what this means is that in any sort of data set is that you'll get, if I drew a stem and leaf diagram for, let's say, 50 values for some survey that you took, let's say household incomes, so you have, I start off with 20k, 30k, 40k, 50k, 60k, 70k. You would have lots of values here. Okay, and then you get low values there. So if I sort of drew the shape of the graph there, it's okay. So a stem and leaf diagram like this would have negatively skewed data. All right, okay, and the opposite is when you have positively a positively skewed data here. All right, but when it's negatively skewed, you'd have the opposite. So let's say for a given region, now this would be for a more affluent region in this country. Okay, this is what you'd get. Okay, where it's negatively skewed. Okay, so it'll look like this. Okay, most people earning in this range. Okay, symmetrical, you would imagine it'll be bulging in the middle, and at the extremities you'll have low numbers. All right, but how do we so what's the test that we use? What are the tests that we could use to determine whether it's positively or negatively skewed? All right, if you had a question that involved the box plot, okay, you'll have to use this test to say whether it's positively or negatively skewed. Okay, so if the difference between the upper quartile and the median is greater than the difference between the median and the lower quartile, okay, it's said to be positively skewed. Okay, alright, let's see how that works. Okay, now try and imagine for this sort of data what your lower quartile, upper quartile, and median could have been. Alright, just take a moment, I'll show that you in a minute. Okay, the lower quartile could have been something like 25,000, the upper quartile could have been something like 60,000, the median would have been 30,000. Okay, because there are lots of values clustered around this area here. Okay, so if you look at the person at the 25th percent level, okay, he'd probably be earning this much, and the person who's at the 50th percent level, that's probably here, somewhere here, he'd probably earning 30,000 pounds. Okay, the upper quartile, because there's a large spread in this area, the person at the 75% level would be somewhere there. So I'd be safe to say that's about 60,000 pounds. All right. So if I sub these values in, that's what I get, and I can indeed see that the difference between the upper quartile and the median is greater than the difference between the median and the low quartile. Okay, if the inequality sign yielded a value where you had to put a sign the other way around, then it's negatively skewed. All right, so you do the same test. Okay, find the difference between the median and the upper quartile and the median and the low quartile, and see which one's bigger. If this difference is bigger, then it's positively skewed. If this difference is bigger, then it's negatively skewed. All right, and if there's almost no difference at all, it's symmetrical. All right, there's very little difference between this and this and this and this, then it's symmetrical. All right, so that's one test. Okay, another test that you can use is if they didn't ask you to draw the box plot, and if they gave you the mean, median, and the mode values of that. Okay, a positively skewed data would have most likely have the mean, median, and mode at these points. Okay, now you need a little bit of imagination here. All right, the mean would probably be somewhere here. Okay, remember, we don't use mean as a measure of average for skewed data, because these lower values here are going to pull the mean further up. Okay, even though you have majority of the people in this sort of region. Okay, so the mean is going to be there. All right, so that's the mean, and the median would be more or less at right somewhere on the peak. Okay, but it won't be exactly on the peak. Okay, more or less somewhere on the peak. So that's the median. But the mode would be always the category that has the most number of people. So that's on the peak itself. So that's the mode. Okay, so if you get a situation where the mean is greater than the median and the median is greater than the mode, you can say that's positively skewed as well. Now this is actually the most weakest way of showing skewness. Okay, so you'll only do this if you had a question where you'd had to only work out the mean, median, and the mode. Okay, if you had the box plot available, you have to do the other test. All right, this is actually a very weak test. Okay, so if you had a situation like this, it'll be positively skewed, and if you had a situation like this, it'll be negatively skewed. Okay, negatively skewed. All right. Now there's another test you'd have to do. This is in fact the most complicated test. All right, there's a formula that you need to remember. This is the formula. All right, so if you substitute the values of the mean, the median, and the standard deviation into this formula, the answer that you get from this formula, all right, you can get a positive value, you can get a negative value. You most likely get values around about 1. Okay, so if you get a value like 0.5, you'd say that's positively skewed, and that's actually quite a strong positive skew. All right, so the more it veers towards 1, it's a strong skew. All right, so if you got a value like minus 0.4, you'd say it's a negative skew. All right, and if you had a very sort of low value which was very near 0, you say there's little or no skew. Okay, so if you get a positive value, you say it's a positive skew, you'd say little or no skew, or you say symmetrical. Okay, very rarely you'll get a value which is exactly 0. Okay, 0 is, well, it'll be ideal, you can call it symmetrical without any hesitation, but very rarely you get that. Okay, now how do you think this thing works? Now why would this work? Why would this formula work? Okay, we'll look back on to this diagram here. Now if it's positively skewed, you always see the mean being above the median. The mean value is always above the median. That's because all these high values pull the median up. Okay, whereas the median doesn't get affected by these extreme values. Okay, so the difference between the mean and the median, if it's positive, then it's positively skewed. Okay, now they want to divide it by the standard deviation, so that you can sort of get a better idea of this precise skewness. Okay, Now I can draw you two types of skewed data. Okay, so that's one type. Alright, and I'll use another color. Okay, now this I'll start from here. Okay, now let's say both of these have the same mean, sorry, that's the median, same median and the same mean. Alright, but the one in green actually has a lower standard deviation, sorry, a higher standard deviation, beg your pardon, because there is more variation. Okay, there's more variation, okay, than the one drawn in white. That has a lower standard deviation. So therefore, if you did the formula for the one in green, it will show a skew that is less than for the one in white, because that has a lower standard deviation. Okay, because that standard deviation is lower, so it will divide this value and give you a higher value. Remember, if you're dividing the same value by a low number, you'll get a high value. So therefore the skew is high. Okay, even though these two have the same mean and the median, the skewness, okay, for this would be, the green one would have a lower skew and the white one would have a higher skew. Okay, alright, good. Hi there. Now we're going to look at histograms. Okay, now histograms are used in cases like this. Okay, now let's say you're trying to move to another country. You want to go to a country where you have a good number of days where you got warm weather. Okay, and then they say in their brochures that from 0 to 5 degrees centigrades we have 100 days per year. Okay, and 5 to 10 another 100 days, 10 to 15 80 days, 15 to 30 80 days. Okay, now if you look here, the temperature ranges are, you think it's going up by 5, but when you get to here, it's actually going, it has 15-degree range there. Okay, so if you drew the frequency chart for it, okay, so let me show you the frequency chart. Okay, so if you drew the frequency chart for it, it'll look like that. Okay, so you'll think that it's quite temperate looking at this. Okay, because there are peaks that's it's all around the same sort of height. Okay, so you got 80 days where the temperature is 15 to 30, 80 days where the temperature is 10 to 15. Okay, but they've actually skewed the data so that, you know, it gives a wrong impression. Okay, you see this last category, 15 to 30, that hasn't gone up by 5, it's gone up by 15. Now the histogram though, okay, would take the class widths also into consideration. Okay, now I'll show you how this histogram looks like for this. Now that's how the histogram looks, okay, for this frequency graph. Okay, this is the histogram, and you can see that I have given the spacings between classes. Okay, I have spaced them out in accordance to how big the class is. Okay, so if there was a 15-degree width there, I made sure I showed that. Okay, I gave an equivalent space to that. Okay, and on the y scale you have the heights which equal to the frequency density. The frequency density, you figure it out by dividing the frequency by its class width. Okay, the frequency here is 100, the class width is 5, so the frequency density there is 20 for this as well, 16 for the third category. But if you notice, for the last category it had 80, just like the previous category, but the class width is larger, so I got to divide 80 by 15, which is approximately 5.3, and you can see it looks like the graph looks less rosy now, doesn't it? Okay, now you would think twice about moving to this country. Okay, because they say, okay, the temperatures aren't too bad looking at this graph, but if you look at its histogram, in fact most of the days it's quite cold. Only very rarely do you see, you know, temperate days where it's quite sunny and hot. All right, so that's how you use a histogram. Okay, and if they started off with this, they didn't give you this table to work out how much each block, how many members, or in this case how many days in each block do you have, you multiply the class width by the frequency density and you get the frequency. So if I just do class width times frequency density, I get my frequency. So if I didn't know this table, but they gave me this table to figure out how many are there in this block, I do 5 times 20, which is 100, so that equals to 100 days. Okay, so that's how you work out the individual numbers of each of these blocks. Okay.